Now, in the Open RAN, okay, in the Open RAN, the approach right now is to improve the implementation. From the closed approach, like for example, you have a closed system for RAN, and then you have the core network in which you have a single vendor, like for example, Ericsson, Nokia, Huawei, ZTE, or Samsung. So this is monolithic in approach, monolithic. So it's only one block. And then it's vendor dependent also, roadmap. So whenever the vendor would like to implement a new feature, so sometimes operators are pushed to get that certain upgrade. Like for example, you cannot deploy 5G unless you upgrade your network software into this level. Like for example, in your iOS, if you have a phone or Android or iOS phone, there is a software upgrade, right? So iOS 16, like that. So in the network, we also have like that. And some functionalities you cannot do, you cannot implement unless you upgrade your software network. So that becomes dependent. So in case that there is no improvement in the vendor's roadmap, so your network will become stagnant. And it enforces vendor lock-in. Okay, so you are locked in, so you don't have any more choice. You cannot change equipment from different vendors. Well, you can change, but it will take you more resources, more time, and inconvenience when you are swapping. I believe everybody, someone here already experienced the network swap, where you are changing the equipment from one vendor to another vendor. It's very difficult, specifically if you're RF or optimization or operations. When you change equipment from one vendor to another, it's very difficult. No, it will cost you your sleep time become lower. No, malagi kayo mapupuyat. Okay, and best effort and limited elasticity and SLA variety. Okay, now going to Open RAN. Okay, we have the closed RAN. Now we go to Open RAN. Okay, when we go to Open RAN, so remember, so we have the different RRU. RRH is same as the RRU. Okay, we can use different RRU from vendor 1, vendor 2, vendor 3, vendor 4. The same time, you can connect it also from vendor, like for example, vendor 1, this is vendor 3, this is vendor 5, and this is vendor 6. Okay, so you can interconnect it. So you will have a multi-vendor capability in your network. So the new challengers here are, like for example, in the names of Mavenir, Acceleran, Parallel Wireless, Radisys, Nuran, Winstron, or CloudStreet. So it enables elasticity, enables multi-vendor system interoperability, and open and disaggregated interoperable and secured RAN architecture. And the service level SLA enabler and service-based KPI. Okay, so that is the vision of the Open RAN system, because there is a problem, no, that the operator is now experiencing. So this sometimes is the problem of the vendor. Okay, aside also from the cost, right, when they are implementing. So what are those key operator challenges? No? Like for example, faster time to market. So faster rollout for new features, services, and capabilities. So whenever they want to launch, like for example, 5G technology, so they need to be fast in the rollout. And then when you roll out a new technology, it requires significant investment. So you need to purchase not only equipment, but also software, features, manpower, okay, and resources to implement that. And in terms of flexibility, you are looking at, for example, can I use my existing equipment? Can I use my existing baseband unit? Or can I use my existing RRU to implement that new technology? Sometimes it's not. Like for example, when we implement the 5G, you need to buy new RRU. You need to buy new new baseband unit, no, to support the 5G deployment. So that is one of the operator challenges. Next is the better performance. Okay, better performance. So as your network expands, okay, so you need to improve the system capacity. Like for example, yung problema kanina ng isa, no, malakas yung signal but the data is slow. So that is one of the example of better performance. Dumadami yung subscriber mo pero yung capacity mo hindi. So you need to have, of course, better coverage. If you want to increase the subscriber base or footprint, you need to increase coverage. But at the same time, you need to increase the capacity. And then if you increase the capacity, increase the coverage, there's a trade-off again. There's an interference. So you need to enhance the quality of service. So the better performance is it does not only take expanding equipment or additional frequency. You know? So it also takes the improvement of the QoS. And then lower cost. So you cut in energy consumption. So the more cell site you build, the more power you consume. Because you will build something, right? And then you will have power source. Like for example, tapping to the Meralco or putting another generator, okay? Putting another solar power system or putting battery system in your cell site. So it generates a lot of electricity. So you want to lower down the energy consumption and then lower the equipment costs. So when you build the network, you want to have lower equipment costs. So remember, you have this we will discuss it later now. So, and then after that, when you try to build the network, you will have this capex. Capex is what we call the capital expenditure. So this is the cost criteria used when you are buying equipment, licenses, software. So we use the capex. We call it capex. When you buy something and use the money to buy equipment, services, or licenses, software, we call it the capex, capital expenditure. When you use the money for operations and maintenance, okay, by paying of bills, so electric bills, gasoline, paying for the highly paid RF engineer or optimization or operations team, we use it as an OPEX, operational expense. Now, one of the problems of one of the challenges, no, of operators is maintaining the business model, no. Like for example, we have what we call the payback period or the ROI, rate of investment, no. Yeah, rate of interest. Yeah. Okay. So when you compute this, sometimes it's called PP, no, payback period. When you compute this, normally you will have the capex on top. Okay, you have the capex on top. And then you will have your what they call revenue. How much you earn every month, revenue. Okay. Minus the operational expense, the OPEX. Okay. So if your capex, like for example, my capex is around 5 million pesos, okay? And then my revenue is around 3 million, and then my OPEX is around 100,000 or 100,000 pesos. 100,000 pesos. So what is my PP? What is my ROI? Can you try to calculate? What is my ROI? So if my cell site cost is 5 million pesos, so 5 million divided by 2,900,000. 2,900,000. So my PP is how much? 5 divided by 2.9. It's 1.7, right? 1.7. So meaning in the 1.7, I can get back all the expenses I made in 1 month. So that's how you calculate the ROI. So within 1 month, makukuha mo na agad yung ginastos mo. So but it's not the same in different, it's not the same for all, for all cell site. Some cell sites have lower capex. Like for example, yung kalsada. Wala namang, kunyari, dumadaan doon isang tao or isang sasakyan kada isang araw. So the capex, the revenue there is very low. Okay? And the capex is very high. So sometimes ang ROI mo umaabot ng mga more than 72 months, no? Yan. So meaning the capex is not so, the ROI is not so healthy. So for us to lower the cost, so we need to find a way to lower the capex, okay, maximize the revenue, and lower the OPEX. So your ROI goes up. Okay? So para meron tayong business case. Other than that, kung engineer tayo na nagpo-propose tayo ng magagandang system, but there is no business case study, malulugo yung company, no? Yeah, so kaya importante yan. Okay? So, this is where Open RAN comes in. Okay? So, this is where Open RAN comes in. So, as we all know, right now, the current traditional network, this is based on the telecomlead.com, no? In the 2021 worldwide global market share, 29% is Huawei, Ericsson is 15%, Nokia is 15%, ZTE is 11%, and Samsung is 3%. So in terms of the elements of the mobile network, the antennas, you can use different vendors, different manufacturers, but the remote radio unit, the baseband unit is what we call the closed front hole. No? So you will buy it in a single vendor. You cannot combine or you cannot mix and match different vendor of radio unit to the different vendor of baseband. And your CPRI or your front hole is also proprietary. So this system creates vendor lock-in. It fosters dependencies and less and fewer vendors. So what happened in the telecom industry? So they adopted the path taken by the IT industry, which happened in the core network. In the core network, it already happened that they have a disaggregation. They disaggregate the core network hardware and the software. Now they want to implement it in the RAN, in the radio access network here. They want to disaggregate hardware from the software. When we say disaggregation is the splitting of the system into smaller subsystems. And this means separation of the hardware and software. And then for Open RAN, we focus on the disaggregation of the radio access network component. So this one. So we are focusing on here. Okay. Now, what happened to the radio access network? No? What happened to the radio access network? When we say disaggregated RAN, okay, so from the core network, it's still the same. So we are not doing anything in the core network. So what we are touching is the traditional RAN. So in the radio access network, first we will have a different steps. First step is to disaggregate the hardware and the software. Okay. So we will, for example, in the case of the BBU, we will separate the BBU into two: the CU, centralized unit, and the distributed unit. Okay. Next is to open the front hole. This one we need to open. It should not be proprietary. If the front hole is open, meaning we can connect any equipment coming from different vendors, which is also open, to each other. We can mix and match. Third is enable intelligence in the network through the RAN intelligent controller. So this is a new component introduced by the ORAN Alliance, the RAN intelligent controller. So this is powered by artificial intelligence. Okay. So when we talk about open, okay, we mean open source software, open source hardware, and open interface. And then open refers to the intentional capability of the software, hardware, and interfaces to comply. Okay, there's a word, comply with an agreed upon standard like 3GPP and the ORAN Alliance. Okay. Now, when you try to read more about Open RAN, there are different terminologies that you will encounter. Okay. So you will encounter three words, like for example, Open RAN with a space, Open RAN without space, and then the ORAN. So what are what are the differences, no, between these three words? So let's make it clear. So when we say Open RAN with a space, okay, Open RAN with a space, Open RAN is a broad term to describe disaggregated RAN solution built on open COTS hardware and open interface standards. Okay, so this is the movement that we are currently doing right now, Open RAN. But when you see the word Open RAN without space, it refers to the TIP project group and concept. So it defines a vendor's neutral disaggregation of RAN at both the hardware and software levels. So this includes the virtualized and integrated RAN solution. So this Open RAN is under the group of Telecom Info Project. So there is a separate group under TIP, which we call the Open RAN. Next is the ORAN. So when we say ORAN, it refers to the ORAN Alliance, which is the operator-founded organization defining standards for next-generation RAN architecture. So this is the standardization body, ORAN Alliance. This one is under the TIP project group, and this one is the movement. Okay, so when you see these three words again, so you need to understand that they are different, no, to each other. Now let's go to the Open RAN. So what is Open RAN, sir? What is really Open RAN? So Open RAN means Open Radio Access Network. So this is an industry movement that develops disaggregated and interoperable radio access network solutions that leveraging on what? 3 GPP processors or general purpose processors hardware, software-defined technologies, and open interfaces. It's almost the same actually in our implementation of radio access network. It just so happened that we are using open interfaces and GPP processor. So meaning you will not mandated to buy a specific equipment from a vendor, from a traditional vendor. You can buy an x86 processor from any OEM or ODM manufacturer. Okay. So the distributed unit is GPP, and you can have a software. No, okay, that is also capable of installing in any of those hardware. So before we evolve in the Open RAN, so there is an evolution happened. Okay, so what happened here? We started into traditional network. So we have this what we call the traditional network, the distributed RAN or the DRAN, where yung ating baseband unit and yung radio unit is located in the cell site premises. Okay? And the equipments are all proprietary. Then we go to the centralized network. The centralized network, what happened, yung mga baseband natin will become baseband pool. So when we say baseband pool, it's also known as yung mga baseband hotel. Buti pa tong baseband, no, na Hino Hotel. So baseband hotel. So they are located in a central office or a data center. And then ang naiiwan sa in our cell sites are the radio unit. And then what happened in the virtualized RAN or the vRAN, the functionality of the baseband becomes virtualized. What does it mean, no? Dati meron kang radio. So when you buy a radio, So you buy a specific radio, no? AM radio or FM radio. You buy an FM radio. And then when you buy it, there is a hardware, okay, physical entity of the radio, and then there's a tuner, no? Same thing also here. When you buy a baseband in the centralized network or in the traditional network, when you buy a baseband, you will have those functionalities. But in the virtualized network, the functionality of the baseband unit becomes virtualized. What do I mean by that? Remember yung radio nyo dati na binili? Now, the radio functionality is virtualized, meaning you can install the radio app in your iPhone or in your Android, and you can play the radio using your phone by installing that app. You don't need to buy a radio, a physical radio, in the banqueta or in the mall. You can just install the app of the radio, and then you can play it. You can find the radio station, and then you can hear also the same, no, same music as a traditional radio broadcasting station. So that's what we call the virtualization in simpler terms. So there is a separate topic of virtualization in the Asia Open RAN Academy. So in this introduction, we will just having a preview on this one. So the software functionality of the baseband is virtualized and installed in this COTS server. When you say COTS, it's commercial off the shelf. Okay. And then your radio unit is still on the cell site. But what is the happening in the virtualization? Although you virtualize the functionality of your phone, okay, your interface is still proprietary. Still proprietary. You cannot still connect different hardware in this one because your software is proprietary, but your interface virtualized, and you're using a COTS hardware, but your interface is still proprietary. So you cannot mix and match until such time we go to the Open RAN. When we say Open RAN, so we are implementing the 3GPP CU-DU split, okay? And then what will happen here, the cloud native functions of this one, so this 3GPP hardware, and then the interfaces is open, okay? So you can have a disaggregated multi-vendor interoperable hardware and software. So this is one of the advantages of Open RAN. Okay. So when we implement Open RAN, it will have a different benefits. So we will have a diverse vendors ecosystem. So there will be a lot of vendors coming in. So it will remove the vendor lock-in. So it will allow more competitive supplier environment, faster network deployments due to the automation and centralized radio architecture. And then new innovation models that will be introduced, make it more accessible to the third-party developers. And running automation models. So we will have automation models and data-driven based on artificial intelligence and machine learning. So, okay. And then we will have a lower total cost of ownership. So TCO. So total cost of ownership is that this is the cost you use when you try to buy that network plus the maintenance cost. So that is the total cost of ownership. So the total cost of ownership will become lower because you will be using a remote unit of white box concept. So you will buy this white box RRUs, which is lower in cost compared to the RRUs of the traditional vendors. COTS servers, like for example, the one that we have introduced in the BBU. So you can buy the COTS servers like the x86 processors. The CI/CD, continuous integration and continuous deployment approach in testing and validation of softwares. And also reduce time to market and time of deployment. Okay, so since the network will become powered by virtualization, So anything that you want to configure, like for example, you want to deploy some additional carrier, so you can just have to configure it. No need to go on site, put the additional hardware for the additional carrier, or install another remote unit on that one. So you can do it remotely and through the power of virtualization. And reduce equipment maintenance costs. Okay. There are drivers for the Open RAN. So the disaggregation solutions based on the open interfaces and cloud technologies can help provide the CapEx and the OpEx efficiency and network flexibility. So it includes growing network demand. So as the Global System for Mobile Communications, or the GSMA, forecast from 2019 to 2025, the average amount of mobile data used by subscribers around the world will become ×4. So in order for operators to properly deploy the capital and keep up the growing demand of their networks, so they need new techniques on this one. So Open RAN, which enables multi-vendor RAN solutions, it provides freedom to optimize each component of the network while simultaneously lowering the total cost of ownership. And then network virtualization. So the network virtualization demonstrated already in the 4G core network during the times of LTE. So the agility has been already proven. So that's why they are implementing it also in the 5G and the Open RAN. And the development of the cloud computing has made it feasible to virtualize the radio access network, which gives way to more efficient and less expensive solutions, as well as faster innovation cycles and network administration that is fully automated. So remember the radio that I mentioned a while ago. So whenever you want to create more radios and then give it to your subscribers or to your friends, why don't you just create a software of a radio app and then they can download it anytime? And if you don't want the radio anymore, they just delete it on your phone. So that's the power of network virtualization. So it fasten the deployment procedure. And then the booming of the artificial intelligence, machine learning, and big data. So we want to capitalize this technology. So as you can see, there is a merging of IT skills and telecom skills when Open RAN comes in. So this creates a new opportunity, especially for us in the telecom industry, to learn more new skills in the IT industry, and then the IT industry to learn more about telecom skills. So when you combine those skills, you can efficiently perform better in the Open RAN ecosystem. Okay. And of course, the 5G use cases. So we have a lot of 5G use cases, like I mentioned a while ago, the URLLC, the MMTC, and the massive machine type communications. Okay. So I know that you are wondering, so aside from the drivers and the benefits, probably there's a lot of challenges when deploying Open RAN. Okay, so let's discuss the Open RAN challenges. First challenge is network performance. So there's a lot of people that are trying to challenge this one. How about the performance compared to the traditional vendors? So common concern, this is a common concern regarding the Open RAN. So is the ability to match the performance of the proprietary hardware platforms. So the recent lab trials and live deployments, like for example, when you check on the Rakuten's deployment, we will discuss it in the ORAN use cases. I will show you the Rakuten story to support this network performance topic. Okay, so it addressed at the end of this module. So that module are the proof of the Open RAN is meeting the performance objectives. Next is the fault management. So when something goes wrong in the network, this, right? Pinpointing fingers. Isolating the component is the source of the problem can be more complex in Open RAN because you don't know. If you combine two equipment, from different vendors who will do the fault management, no? Who will do the troubleshooting. So to solve this challenge, network management tools have been developed for Open RAN. So contributing to root cause analysis and speedy issue resolution. Okay. Next is network automation. Okay. Network automation to fully realize the benefits of Open RAN and to manage complexity, operators must invest in the cloud management technologies and extreme automation, including the orchestration and what, for example, the Rakuten has implemented in their network. We call it the zero touch provisioning or the ZTP. Okay. And another one is understand the Open RAN ecosystem. Okay. That's why we are here, right? One of the biggest enhancements to Open RAN is the end of the vendor lockdown age. So in the new Open RAN environment, a lot of different new vendors are appearing to supply hardware, software for each element of the network. And then for this reason, it is important that everybody involved is aware of all new hardware and software that currently exist, as well as all providers. For this issue, there's a lot of initiatives were being born to help companies understand and begin in this journey. And one of the good example of this initiative is the Asia Open RAN Academy, right? Actually, we are training the engineers on the coming future of the radio access network because this is coming. Okay, so we need to understand what are the different components in this Open RAN ecosystem so that when Open RAN comes here in the Philippines, we are all prepared. And of course, new team profiles. So in Open RAN, like for example, in the cases of operators, the lines, as I mentioned, the lines between the world of telecommunications and the world of IT is now becoming blurred, no? Medyo, ano ba to? IT ba to? Or telecom ka ba? Or what? Nagiging blurred na, no? Kasi, like for example, some telecom engineers are studying Python, some telecom engineers are studying virtualization, some IT engineers are studying RF. Okay, so the thin line or boundaries become blurred, no? Nagiging ano na tayo, nagiging mix na tayo. So this implies that the roles and responsibilities are defined so far within the world of mobile network change with the arrival of Open RAN. It will change. So if there is a change, right, we are forced to change also to survive. That's the rule of that's the law of survival. No? For this reason, one of the challenges that the companies, like for example the operators, is facing is the adapting of their team and knowledge to this new way of deploying networks. So for example, meron ka mga team ng RF, no? Gusto mo matuto ng Open RAN, kinakailangan mo i-train yan. Okay? So for us, for example, wala pa tayo sa operator and then we want to go to an operator, you want to join an operator or a vendor, and then you are equipped with this Open RAN skill set or knowledge, so it's easier for you, no, to get that opportunity. Okay, so at least we can say that we are on the right track. Okay, next is the Open RAN main challenge. So the main challenges is actually the system integration. This is one of the challenges na nakikita nila, no, na malaki ang impact. The system integration. So integrating components from different vendors. So there is a study that I have read na kino-compare nila, no. Mura nga yung equipment. So the equipment cost, software is less costly compared to traditional vendor. But there is an additional scope that will be added. And you know what's that additional scope? Integration. So we don't know yet how much would be the integration will cost. And then you will need additional player to do it for you. Like for example, in an operator, if your personnel are not yet equipped to do the system integration of a different vendor, so you need to hire an external source, right? So when you incorporate that cost to the total cost of ownership of the Open RAN, what would be the difference? Okay, so that's why there's a lot of operators now that weighing, if they will be applying the Open RAN system in their network or not. Maybe they are hesitant to do it because the cost implications and the business case is not yet so clear, no? Kaya ina-identify agad natin 'yan. Okay? So, yeah, so this must be accomplished while assuring deployment readiness, okay, which includes interoperability between the ORAN components and legacy equipment and extensive testings, okay, and increased vendor collaboration. So let's take a look at the different GPP hardware. Okay. So meron ba tayong mga GPP hardware na makikita no, sa industry? So we have, like for example, you can check out this website, the www.srslte.com. So let me just share with you. Okay. So when you look at this website, so pag tinignan nyo yan, so you can see the full suite no, of SRS RAN. So it's a own mobile network. No? So this is an open source 4G and 5G software radio suite developed by Software Radio Systems or SRS. So when you browse it sa inyong mga computer after this session, I'll give you time for this one until the next session. So it part 2 ng ng mga learning activities. So you will look at into this. When you click here, so you will see the different Open RAN equipment. Tapos nandiyan na rin yung kanilang mga software. So you can practice it actually, no? So the all SRS RAN software runs in the Linux with off-the-shelf compute and radio hardware. Okay? So nandiyan na rin yung document. Okay, so you can also see the document here and the manuals. Okay, so when you click this one, okay. So nandito na yung mga nandito na yung mga specifications, okay, user manuals ng Node-Bs, features. So when I first look at this, I remember when I was browsing the library of the vendors. It's just like vendor library, open to everybody. So when I was working with Ericsson, there is a library like this. So if you nasa vendor side ka, ito yung dapat binabasa mo lagi. Kasi para maging sharp ka no sa inyong mga equipment, how you configure the equipment, ano yung mga specifications, how do you document the configuration if you want to master the configuration and integration, yan, no, optimization. Nandito lahat yan. Okay? So nandito na yung mga commands niyan and then yung mga configurations nandito. Okay? So that is the example of the GPP hardware and open systems. Okay, and then we have this open air interface. Yan, openair-interface.org. So kasama rin ito sa ninyo. So just browse it na lang para makita nyo ano yung meron dyan sa open air interface project na yan. And ito yung mga samples ng USRP, Universal Software Radio Peripheral. It's a range of software-defined radios designed and sold by Ethos Research. No? Yan, ito rin mga mga universal software peripherals na ginagamit natin na pwede nyo gamitin sa Open RAN. Okay? So nandun din yan sa inyong sa inyong sources. Sa inyong mga tawag dito. Dun sa inyong mga learning activities. Okay. So we have a scheduled break time, pero I think we will be limited sa time. Kaya itutuloy na natin sa ecosystem ng Open RAN. Okay? So pag-usapan natin who are the players here in the Open RAN at sino-sino yung mga dapat nating manmanan na maaaring maging maaaring maging team player natin or maging ka-collaborate natin in the future when Open RAN comes in here in the Philippines. Sabi ni Albert Acosta, is it seamless to implement telco carrier interconnections in the Philippines using Open RAN? In terms of interconnection kasi nangyayari yan sa core network. But there is a use case na pag-uusapan natin sa fourth session, which is the RAN sharing. Okay? So it's not an interconnection, but it's a RAN sharing approach. in which yung sa isang radyo, yung dalawang operator pwede mong pagsamahin. Like for example, Globe and Smart, they can share the same radio. We call it the RAN sharing. Kasi yung interconnection nasa core yun core network. No? So RAN sharing tayo. So there are two types of RAN sharing, yung MOC-N, multi-operator core network, and the MORAN, multi-operator radio access network. Okay? So pag-usapan natin yan sir sa use case natin. May idea po kayo sir kung may SRVC provider na tayo sa Pinas na nag-implement service provider na nag-implement sa nag-i-implement ng Open RAN. Yung mga existing operators natin like Globe and Smart, they are looking into this. So si Smart, kung sumasama kayo dun sa Open RAN sessions natin every Wednesday, which is maililipat na natin na Saturday, kasama natin do si Smart. Si Smart is a member ng NGMN, no? Next Generation Mobile Network, which also looking at the implementations ng Open RAN. So right now, sila is nasa evaluation or testing stage ng Open RAN. Okay? So, let's take a look sa Open RAN ecosystem. So, tingnan natin itong mga to, no? So, Open RAN ecosystem, meron tayong Telecom Infra Project, meron tayong ORAN Alliance. We have also the other Open RAN groups like ORAN Software Community, Small Cell Forum, and Open RAN Policy Coalition. So, sino-sino itong mga to na engage sa Open RAN? Let's take a look at Telecom Infra Project. So, this is the first of the two industry groups spearheading the Open RAN initiative. So, TIP or Telecom Infra Project is founded or was founded in 2016 by, tingnan nyo kung sino, Facebook. Or mas kilala ngayon sa tinatawag na Meta. As an engineering-focused collaborative technique for designing and implementing yung global telecom network infrastructure. So, pagkatinignan natin si TIP, ito yung kanilang website. So, kanina may nakita kayong group, di ba? Yung sa terminology ng Open RAN. So, when we talk about Open RAN na may walang space, ito yon. And the subgroup siya ng Telecom Infra Project. So, when you click at Open RAN, so this is subgroup project initiative to define yung and build yung 2G, 3G, 4G, and 5G solutions. Okay, so they are the ones creating this ecosystem. Yan, si Open RAN. So marami din kayo matututunan dito kay TIP. Okay, so isa to sa partner ni Asia Open RAN Academy, si Telecom Infra Project. And then kung papalarin by the fourth session, ma-invite natin sila Indonesia. Sa Bandung, Indonesia, sila Telecom Infra Project sa Telcom University para ma-access natin yung ating mga nodes dun sa kanilang laboratory. Okay? Next is, sino pa? Ito, si ORAN Alliance. Si ORAN Alliance, which was formed in 2018 with the goal of promoting open and intelligent RAN. So this is the second organization driving the Open RAN movement. So mas sumunod siya, no? Mas nauna talaga si Facebook. And then sumunod to si ORAN Alliance. Si ORAN Alliance was created by merging two organizations. Una, sila CRAN Alliance, which is headed by China Mobile and other mainly Chinese vendors. And then sa kabila naman, si XRAN. Kasama niya dito si NTT Docomo ng Japan and other mainly American vendors. So nung nag-merge sila, ito yung mga founding operators. So these are operator, no, founded. So mga operator ang mga nag-umpisa. So kasama dito sila AT&T sa US, China Mobile and China, Deutsche Telekom, NTT Docomo, Deutsche Telekom ng Germany, NTT Docomo ng Japan, and si Orange ng France. Okay? So si ORAN Alliance is a group of telecom companies. Remember, a group of telecom companies to aim to improve the performance and openness of their network. Not only to open their network, but to empower it with intelligence through machine learning or artificial intelligence. Okay? So pag tinignan natin si ORAN Alliance, ganito naman siya, no? So pumunta kayo sa ORAN Alliance, So I encourage you to browse this sa inyong mga asynchronous activities. Okay, so when you browse it, mga documents na dapat yun ang binabasa nyo. So like for example ito, no? So if you want to go on the specifications specifically for Open RAN. Okay, thank you. All right. So I want you to go sa ORAN specifications. So don't go sa membership kasi kung di naman kayo magpapa-member, di ba? Dito na tayo sa specifications. So when we go to the specifications, I want you to download the specifications. Okay, so there is a link that you can download all the specifications. When you download the specifications, it is in the Word file. Okay, so right now, what I'm trying to do, because I'm one of the instructors sa Open RAN Academy, it's my duty to read almost all of these specifications. So it's tedious actually, no? Ang dami, no? Like for example, I'm reading more about the interface use cases, okay? But for you, just download here in the architecture. So when you click the download, okay, so like for example, download ko lang, no? I-download natin yung sample dito para at least alam nyo gamitin, ano? Ayan, so when you download it, so it's free to download, no? So when you download it, the specification would be like this. Yeah. So this is the specification for ORAN architecture description. So what am I say? Why am I saying this to you? If you are really serious in engaging in Open RAN, and if you want to go to become one of the instructors of Open RAN Academy, you need to read. No, you need to learn a lot. And one of the best resources for you is to use these specifications. Ang kagandahan dito is sabay-sabay tayo. Right now, and then in the other parts of the world, nagsisimula pa lang sila. Okay, so for us here in the Philippines, it's the best way to start as well. Okay, so we, just like the board exam, no? Kinakailangan magbasa tayo ng magbasa para mas marami tayong knowledge about this Open RAN. So you can see this is type of specifications. Okay, so there is this definition of terms, just like a 3GPP specification, no? It's the same lang din. Okay, so when you look at this, you can see the ORAN objective, ORAN architecture, which is pag-usapan din natin yan. But here is more detailed, no? Kasi nandito yung mga explanations, okay? It's more detailed. So if you're an ORAN instructor and then you're tasked to create a course about something here, so it is the best resource that you can get. Okay? So nandito lahat yung ating mga resources. Okay? Ayan. So ito yung ating ORAN architecture. Okay. Okay. So ayun yung ORAN Alliance, no? Okay. So the ORAN Alliance is meron siyang architecture. So typical ang architecture niyan is ganitong itsura. Okay, so we have a different architecture and then it is managed and populated by different work groups like the 3GPP. So meron tayong work group 1, which handles, like for example, the use cases and overall architecture. And then we also have the group work group 2, 3 up to 10. Pero right now, I think there is a work group 11 or 12. A work group 11 for security. Okay, so there's a work group already. So these work groups are focused on implementing or creating the guidelines and policies about the different parts of the architecture ng ORAN Alliance. Okay? So ito yung simplified architecture ng ORAN Alliance. So meron tayong Service Management Orchestration Framework, may SMO. So this one is the one managing or orchestrating all the functions and tasks in the radio access network, powered by non-real-time RAN intelligent controller. So the non-real-time intelligent controller, these are the tasks greater than 1 second. So any task greater than 1 second, it is handled by the non-real-time intelligent controller. Going down, connected by a A1 interface is the near real-time RAN intelligent controller. Nandito yung mga XApp. Okay, so sa use cases natin, papakita ko kayo na isang sample ng XApp powered by Remedo Labs. Okay, and then nakita nyo na dito, nandito na si CU, si DU, si RU. So which is nagkaroon lang ng kasi open, no? Open na yung mga hardware natin dito. And then the following interfaces. As you can see, yung mga interfaces natin dito, there are interfaces originated from 3GPP. Yung mga original interfaces na yan, nandiyan pa rin. Like for example, the E1 and the F1 interfaces. But there are new interfaces introduced by the ORAN Alliance like yung A1, O1, O2, at yung E2 interface at front hole. So si ORAN Alliance na nag-create niyan. Okay, kasi hindi yan defined ni 3GPP. Okay, so that's the ORAN Alliance. Next is the ORAN software community. Okay, so si ORAN software community, this is the software, no, developed to for the software. So ang kasama ni ORAN Alliance diyan is si Linux Foundation. Okay, so yung mga software na gagamitin natin sa mga hardware natin is based on the Linux. So yung gagamitin natin na sa pag-access ng equipment dun sa TEL-U is ORAN is a Linux based din, no. Yan. So it is the ORAN software community. So they are developing the software, no, intended for the Open RAN system. Next is the other Open RAN groups. Meron tayong Open Network Foundation, Open Networking Foundation or si ONF. So this is an operator-driven, community-led, non-profit consortium na nagpo-foster of democratizing innovation in software-defined programmable network. Okay, so nasa SDN naman sila, no? Yan. Through the ecosystem, building advocacy. So meron silang mga research and education, and they're accelerating the state of the art in opening and open networking and catalyzing the creation and adoption of open disaggregated solutions and leveraging open source software. Yan. Okay? And then meron tayong isang group na focus naman sila sa small cell. So ito naman sinatawag natin si Small Cell Forum. So si SCF. So nandun din yung website ni SCF sa ating learning activities. So this SCF or the Small Cell Forum is developed or has developed its own Open RAN environment but considering the small cells in mind. So when we go back dun sa splitting, option splitting, okay, sa functional splits, ang ini-implement ni SCF is the split 6. So hinahati niya si MAC and the physical layer. Okay? So doon siya nagfo-focus, no. Nandun si SCF, no. So yung mga small cells. Ano yung mga small cell? Sir, ito yung mga mga lamp site solution na katumbas natin sa sa Huawei or kaya yung mga radio dot natin sa Ericsson. So yung mga IBS natin na dinideploy. Small cells yon, no? So yung sa mga small cells. So application ng 5G, marami kasi tayong small cells na i-deploy. Okay, so kaya si Small Cell Forum, kung gusto niyo namang mag-focus sa mga IBS implementation ng Open RAN system, punta kayo kaagad kay Small Cell Forum. Okay? Also, syempre, ginagamit niya rin si Open RAN, no? Yung specification ng Open RAN. And I think last is the Open RAN Policy Coalition. Okay? So, it's a collection of firms created to support yung mga policies that would accelerate yung adoption ng open and interoperable solutions in the RAN as a method of creating yung mga innovations, stimulating yung mga competitions, and expanding yung supply chain, no, for advanced wireless technologies such as 5G. So ang kanyang mga goals ay yan, fund research and development, remove the barriers, no, yung mga nakaharang sa deployment ng 5G, avoid heavy-handed and prescriptive solutions. So they simplify the solutions and use the government procurement to support vendor diversity. So meron silang mga function na nakikipag-usap sa mga government agencies, no? Yan, sa mga policy creations para ma-implement natin yung adoption ng Open RAN. Okay? And support global development of open and interoperable wireless technologies. Okay? Ayan. So ito yung mga players, no? So yung mga players natin is yan, si Telecom Info Project, ORAN Alliance, ORAN Software Community, Small Cell Forum, and DC Open RAN Policy Coalition. Okay? Sir, meron na ba tayong mga deployments ng Open RAN? So, saan natin gagamitin yung Open RAN? Okay, so ilalagay na ba natin siya agad? So, marami tayong mga deployment scenarios and use cases. And then we have a separate discussion, as mentioned, sa use cases. Deployment scenarios, like, for example, coverage extension and site densification. So, if you want to have an extension of the coverage and we want to save on cost, isa sa mga use cases niyan yung binabanggit ko kanina, no, yung RAN sharing. So where actually yung RAN sharing, it's also an opportunity for other entity. So like for example, isa kang company na natatandaan niyo sila, no, sila tower sharing company. So previously si tower sharing company, they only supply the towers. Okay? But right now, it's a good business case also that to explore the Open RAN. So whenever you offer a tower, why don't you offer the radio access na? Nandun na yung radio access, no? Open RAN. Actually, you will not restrict yourself to buy to every vendor. You can buy this equipment to new players like Mavenir or like Parallel Wireless, and then ask the vendors or ask the operators to, hey, I have a tower here, meron na ring radio access. Aarkilan na lang kayo, no? Ko-connect nyo na lang sa core network. Okay? Ko-connect nyo lang sa core network nyo. And then, yung radio access is automatic na nandun na. So, isa yun sa mga deployment scenarios. New deployments in urban and suburban, specifically, for example, for small cells, no? Additional capacity, like a massive MIMO sites. Okay? System and replacements, no, site replacement. Kung gusto niyo nang palitan yung equipment niyo, pwede na kayo mag-Open RAN, no? Or for example, merong bagong no, ito maganda no, kapag may bagong operator. Kunyari, merong isang operator na papalubog na nagkakaanda no. Off the record muna natin. May bagong papasok na operator, no? So and then they would like to explore the Open RAN system. So when they start a new network, it's based on Open RAN, katulad ng ginawa ni Rakuten. Pag-usapan natin sa Rakuten sa Asia, sa use cases. So it's a good way, no, to implement because it's future proof. Your equipment is based on Open RAN, safe, virtualized, naka-cloud, no? Cloud, tapos naka-cloud, and then naka-containerize yung mga applications mo. Yan. So magandang isama sa study kung kayo may bagong operator. Yan, rural coverage, okay? And then support of private and neutral host networks. So when you deploy 5G, kanina banggit ko, you can deploy 5G like a private network, right? So like for example, meron kang factory and then you want to have radio in your factory for RRU. So you can use an Open RAN radio and then software. And then what you want to do is just connect it to the core network. So the frequency is owned by the operator, but you can supply your own equipment. Okay? And then the operator will give you a specific network slice. Okay, so pwede naman yun. No? And then if you have a specific network slice, hindi na ma-access ng public yung laman ng mga servers mo. So it's private private sa iyon. So isa yun sa mga applications ng 5G na non-public network or NPN. Okay? Mga deployment trials, marami na ang nangyari, pero ang pinaka dominant sa lahat is si Rakuten. Okay? So pag-usapan natin yan sa last session natin. Makikita niyo yung deployment, how many cell sites ang binuo ni Rakuten using the 5G network. Okay? So papaano siya nagsimula from virtual mobile network operator hanggang sa naging mobile network operator na siya. And in some other parts of the world like AT&T, Verizon, T-Mobile, so they're on trial. Okay, no commercial deployments yet. Deutsche Telekom, in Germany, they have a partnership with VMware. So you can just check kung sino yung mga nakikita yung mga vendors dito. I suggest you check their website. Okay, and then check what are the opportunities that is lying there, no? Kung ano yung mga nando na pwede nyo pasukin. Kasi nag-open na tayo, no? It's better to look forward to the future. China, all members of the ORAN Alliance, sila China Unicom, China Telecom, at China Mobile. Okay? Sa UAE, so yung mga kasamahan natin sa Middle East, si Etisalat, okay? Small scale commercial deployment. So they announced it building with Altiostar. So ang kanilang vendor dito si Altiostar and NFC. Vodafone and Telefonica, okay? And then Dish sa US, okay? And si MTN sa announce an open RAN with parallel wireless naman ito. Okay? So let's take a look ito pa. So yung mga deployments natin sa parallel wireless and Mavenir sa Congo, okay? The ano to? DRC, Republic of Congo to no. In Mozambique, okay? So si Mavenir naman diyan ang nag-deploy at saka si parallel wireless. So take a look at this website, no. Si parallel wireless, sila Mavenir, okay? Sa Turkey, si parallel wireless sa kanilang vendor. Sa Vodafone, si Mavenir naman. Merong Mavenir dito sa Pilipinas eh. Yan. So, just take a look at those vendors. Okay, sa South America naman, like the Colombia and Peru and Argentina, okay, parallel wireless din yan. Okay? Sa Brazil, Germany, Spain at UK, itong mga to. Sila Giga-Terra, Altiostar, C-Link, si Mavenir at si Wave Mobile. Okay? So now, tingnan natin. Sir, ano ba yung mga ecosystem ng Open RAN? So marami tayo. So we are separating them in 4 quadrants. Nandyan sila traditional vendors. Okay? Right now, sila traditional vendors, they are starting to join the ORAN Alliance. Si Nokia, nandyan na. Si Ericsson, si Samsung, tsaka si ZTE. Isa na lang di ko nakikita, no? Baka sumali na rin sila. And then meron tayong mga new players. Yan. Si NEC, si Mavenir, si Parallel Wireless, si Fujitsu, si Altiostar. Altiostar katulong to ni Rakuten sa Japan. And then we have the integrators. Okay? System integrators. Those are in the names of Tech Mahindra, Amdocs, Radisys. So if you're one of the system integrators here in the Philippines na nagko-configure, nag-integrate na mga systems, you might want to look at these integrators in Open RAN. Sila Tech Mahindra, sila Amdocs, sila Radisys. So you can align yourself sa kanilang path kung paano nila gagawin yan. And then of course, meron tayong mga chipset vendors and cloud vendors. Nandiyan sila Google, sila Microsoft, okay, si Nvidia, si Qualcomm, si Intel at si AWS. So they are also participating. Last time Google joined the ORAN Alliance. Kasama na si Google sa ORAN Alliance membership. Kaya sumali na rin siya. Okay? And I think that's it, no? For deployment natin, no? So kasi ito ano lang to, no? So in terms of the deployment, pinakamarami ngayon na may contract si Parallel Wireless at si Altiostar. Yan. So yung iba is ito na, no? Yan. Okay, so I think that's it. And that ends our presentation for today. In this 4-hour session, you gain, I think, kahit konting knowledge about Open RAN. And it will help you prepare sa ating mga next sessions. Like for example, deep dive into ORAN architecture, and then the RAN intelligent controller, and the use cases. But I hope you have some idea or glimpse, no, about RAN, lalo na yung sa mga kasamahan natin that is not so familiar about telecommunications or wireless telecommunications. I hope you get some insights, no, and knowledge about the topic for today. Okay, so now we proceed with the Q&A if you have some questions.
Ayan, sir. Another question, sir. Pag nag-ORAN ba tayo, Sir Richard, bibilis ba ang internet sa Pinas?
Yung pagbilis kasi ng internet sa Pilipinas, it's a collaborative effort. Actually, sa case ng mga operator natin ngayon, they are doing their best actually. Kunyari, kung gusto natin bumilis yung internet natin, we are pushing to deploy a lot of radio access network. Nakita niyo naman, no, kinakailangan sa radio access network, kinakailangan natin mag-build, no, para dumami yung mga cell sites natin. And with that kind of approach, we need the support of the government as well. Di ba? So, kinakailangan mapabilis yung proseso natin, mga approvals, yan, mga ganyan. So, kapag nagkaroon tayo ng Open RAN, isa lang kasi sa Open RAN, no, sa sa mechanism natin to have this fast internet. But as I mentioned, it's a collaborative effort from the operator and also from the government.
Ayan, sir, may isa pa pong tanong. Hi, sir. What will be the implication in the transport network when we implement Open RAN, especially meron na pong front haul?
Sa transmission naman, sir, meron din na pagka pumunta tayo dun sa telecom infra project. So they are creating also yung ecosystem for the transmission for the Open RAN. So hindi ko lang alam kasi sa transmission network kung ano yung magiging pinaka-standard nila kasi it's outside the radio access network na. Pero what will happen is that same pa rin naman tayo sa ating in terms of transmission, for example, transmission bandwidth. It will be so much the same with the requirement natin pagdating sa 5G. Remember sa 5G, if we are transmitting a large bandwidth, so kinakailangan natin ng malaking bandwidth in terms of the end-to-end. And then yung ating 5G, meron tayong tinatawag na end-to-end QoS. And then meron din tayong network slicing. So I think ganun din ang i-implement natin pagdating sa transmission. Pero in terms of yung implementation, kung merong Open RAN pagdating sa transmission, that one I cannot answer directly. So pero nandun yung sa telecom infra project. Pwede natin basahin yun para mas makakuha tayo ng maraming information. Thank you,
sir.
everyone. See you next week. Bye.